Hello, let us learn matrix operations. The very first operations are addition and subtraction of matrices. For these operations, the dimension of the two matrices to be added or subtracted should be same as the corresponding elements get added or subtracted. If the dimensions of the two matrices are different, then addition or subtraction is not possible. Addition and subtraction of two matrices gives a third matrix of the same dimension. Here, in case of addition and subtraction, you must remember that addition of a matrix with a null matrix is the matrix itself, and addition of the matrix with the negative of that matrix gives you a null matrix or a zero. When any matrix is multiplied by a scalar, then its every element is multiplied by that scalar. Here the matrix A is multiplied by 4. That is, every element of the matrix is multiplied by 4. Further, the operation of matrix multiplication is very important and used many a times. Remember, two matrices A and B can be multiplied if the number of columns in A are equal to the number of rows in B. A resultant matrix has a dimension as the number of rows in A and columns in B. Let's check whether these matrix multiplications are possible or not. In the first example, number of columns in B is 1, number of rows in A is 4. So obviously, the matrix multiplication is not possible. In the second case, can you guess? Yes, columns in A is not equal to rows in B, so operation is not possible. In the third case, the number of columns in A and the number of rows in B are equal, and therefore the matrix multiplication is possible, and the resultant matrix C is with dimension 2 by 2. Here this describes multiplication of the two matrices. The first row of first matrix is multiplied to the first column of the second matrix, and so on. So in this way, a matrix multiplication can be done. Try out multiplying these matrices. We have to find whether we get AB and BA equal. So if you find AB, you will get a matrix 3, 8, 15, 20. And if you try BA, you will get a matrix 23, 6, 10, 0. So the two matrices are AB and BA are not equal. Next, try this multiplication. What do you find? Can you find AB? Can you find BA? AB is possible because the number of columns in A equal to the number of rows in B, but BA is not possible as number of columns of matrix B are not equal to the number of rows of matrix A. This example has multiplication of two rectangular matrices. The matrix multiplication of these two is possible, and we get a 2 by 2 matrix. If we interchange the matrices, again the matrix multiplication is possible, but the resultant is a 3 by 3 matrix. So again, A into B is not equal to B into A. In case of multiplication of matrices, you must remember that IA into AI is AI is always equal to A. Again, if A into B is 0, then not necessary that either A or B are 0. Another important operation is determinant of a matrix. It is required to compute inverse of a matrix. Every square matrix has a unit scalar value and it is called as determinant of A. For a matrix containing single element, the value of the element is the determinant of the matrix. For a 2 by 2 matrix, we can calculate the determinant as 5 into 1 minus 6 into 2. For a 3 by 3 matrix, the calculations are 1 into 2 minus 3 into 0, that is 0, and so on. In case of determinant, remember, a square matrix A is said to be singular if determinant of A is 0 and non-singular if determinant of A not equal to 0. So in previous example with determinant of A as minus 7, A is non-singular, and with determinant of B as 0, B is singular. With this, from this video, you have learned the basic operations like addition, subtraction, scalar multiplication, multiplication of matrices, and determinant of matrices. Thank you.